So today I want to show you guys quite a tricky law of cosines problem. And this is the kind of challenge problem which really tests your understanding of a certain concept. And so like any other problem, pause the video and try to solve yourself. And if you can't, the rest of the video is dedicated to solving it. And I'll try to make it as simple as possible. So without any further ado, let's get into the problem. So, at 12 o'clock, two planes take off. One heads east at 450 miles per hour, and the other heads 130 degrees northwest of the first one at 325 miles per hour. At what time will the planes be 735 miles apart? So it's best to draw this kind of problem because there's a bunch of words and that might not make sense. And so much easier to just draw it out like I did so. One plane's going 450 miles per hour east, another one's going 325 miles per hour, 130 degrees from the first plane, and we're trying to solve for at what time it will be 735 miles apart, directly apart. And so, we're going to use a law of cosines for this. We have the right side lengths and everything. The issue comes here, and the trick of it is that we know a squared. We know a, basically, the side, 735 miles. And we also know angle A, 130. We don't know side length of B and C, which we need to plug in. Because we only know the speed, which is 450 miles per hour and 325 miles per hour. It's not a distance, it's a speed. And so what we can do is we have the speed and we multiply that by an unknown time, and then we have a side length, a distance. And so we just plug in an x for that. We have this long drawn out equation. And that was really the trick of the problem, is just realizing that you have to use x as a variable of time to find the side length, where you can use law of cosines then. And so from there on, I'm just doing some algebra and simplifying. So I multiplied it out in this step. And then to the top, I just did some combining of like terms. Factored out an x squared, because that's what we're trying to solve for, and get it alone. And divided the whole thing. Then cubed the whole, square root of the whole thing. And then I got that, 1.043 for x, which is time. So 1.043 hours later, the planes will be 735 miles apart. And so to accurately put that in time, multiply that by 60 and you get minutes. Now we have 62.58 minutes later, the planes will be 735 miles apart. 735 miles apart. And so then that just translates at 103, there will be that distance apart. And that's the solution.